All right, we're on lesson 6.1 in our textbook. That is, and it's a little bit of review for us because we covered it using the other textbook. But our objectives are to identify, name, and describe polygons, and then to use the sum of the measures of the interior angles of a quadrilateral. So just a little bit on what all that means. Name and describe polygons means we classify them as triangles, quadrilaterals, pentagons. And so how do we name them based? What are we naming them based on? On the number of sides, right? But what I'm going to focus on in this 5 minutes is a few other descriptions of polygons, like whether they are convex or concave, whether they are regular or irregular, and so let's get to it. So the first example, it says, state whether the figure is a polygon. If not, explain why. Okay, polygon, 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 not a polygon, not a polygon, not a polygon. Okay, why would these not be polygons? Well, a polygon is made up of all segments, and this has a side that is not a segment, it's a curve. So curves are not polygons, or curves cannot be part of a polygon. This one's not a polygon because it's not closed. A polygon's two sides always intersect at two other sides. So it's got to be closed. And this one's not a polygon because it's actually two polygons, right? This is two triangles, but the whole thing is not a polygon. It's two polygons. So there. If you look at it as a single thing, it's not a polygon. Okay. The next example looks at convex and concave, and nicely they talk a little bit about that in the top picture. You can see a convex polygon, and what it's showing is that there's no way to draw. If you extend the sides, they never go into the interior. On a concave polygon, if you extend the sides like this one, it goes into the interior. So that's one way of saying, oh, it's not convex, it's concave, because if you extend the sides, it goes into the interior. Another way of looking at it is you can say a concave polygon is one where you can make a diagonal that goes outside the shape, like these. And that way always worked better for me because then what I remember is that it's like a concave polygon has a little cave on the outside. It's like you could sit in there. So anyway, this one's concave, and this one is convex. Because there's no caves in this one. There's no way, if you extend the sides, just like up here, it does not go into the interior. The extension of the sides stays on the exterior. And there's no way you can make a diagonal that goes outside it, like you can here. All the diagonals go inside it. All right. Then the next issue is what regular means. So, which polygon is regular? Well, you got to know what regular means, and it's right here, right here. A polygon is equilateral if all its sides are congruent. A polygon is equiangular if all its angles are congruent. Its interior angles are congruent. A polygon is regular if it is both equilateral and equiangular. So, is it regular? Here, all its sides are congruent, and these angles are congruent with each other, and these angles are congruent with each other, but the side angles are not congruent with the top angles. I can tell because this one has 2 marks and this one has 1, so therefore no, it's not regular because there's some angles that are not congruent. This one, skipping ahead, this one's obviously not regular. The sides are all congruent, but the angles change. This one has one angle here that's like 280 degrees. So all the angles are not congruent. This is certainly not regular. This one in the middle is our only regular one. 5 sides, all equal. 5 angles, all equal. So B is regular. All right, and then our last example is going to take advantage of the rule that we learned about polygons, the interior angles of polygons. So you might remember that if something has 3 sides, then its interior angles add up to 180 degrees. What you might also not realize, but you can sort of figure it out just by intuition, is that a rectangle's angles, so there's 4 90-degree angles, they add up to 360 degrees. So this is really the rule that we're going to take advantage of here, that the 4 angles of a quadrilateral, even if they're not rectangular, they're still going to add up to 360 degrees. And so you can do problems using that. It's like, oh, if this is 50, and this is 130, and this is 50, then you can figure out this one. Because you know it's got to be 360 minus 50 minus 50 minus 130. And that'll give you x. So similarly, here it says find angle Q and angle R. Well, we know is 80 plus 70 plus x plus 2x has to add up to 360. So we could say 150 plus 3x, because x plus 2x is 3x, equals 360. I'm going to subtract the 150 from both sides. I'll keep working top of the page. And so 3x equals 210. X equals, divide by 3, x equals 70. And so what do we have? Do we have our answer yet? Not quite. Angle Q is x degrees, so angle Q is 70. Angle R is 2x degrees, so we have to say, okay, what's 2x? 2 times 70, okay, that's 140. So now I got it. 70 plus 140 plus 70 plus 80 equals 360. So I found x using the fact that a quadrilateral adds up to 360. So really what I accomplished was this right here. I used the sum of the measures of the interior angles of a quadrilateral and I used it to find a missing angle. So there you go.